Assalamu alaikum 8th chemistry students. How are you all? I hope you all are fine. In previous lectures, I had explained the first part of chapter number 2 that was related to theories and experiments for the structure of an atom. Now, I am going to explain next part of chapter that is about the isotopes. The word isotope was first used by a British radiochemist Frederick Soddy. What are isotopes? Isotopes are the atoms of an element. Atoms of an element whose nuclei has same atomic number but different mass number. What is same? Atomic number is same, and what is different? Mass number is different. So isotopes are the atoms of an element. Atoms mean more than one atom of same element whose nuclei. What is present in nuclei? Fundamental particles of atom, protons and neutrons are present in the nucleus of an atom. So atoms of same element whose nuclei have same atomic number. The term atomic number is related to number of protons. So what is different? Mass number is different, and the term mass number, it's mean number of protons plus neutrons. If protons are same, so what is different? Due to which different mass number is there? It's mean number of neutrons are different. So atoms of same element whose nuclei have same atomic number means same number of protons but different mass number. And here we have seen what is different? Number of neutrons will be different. So it is the definition of isotopes. The word isotopes comes from Greek word isos means same and top mean place. So isotopes are the atoms of same element whose nuclei have same atomic number but different mass number. Okay, now let's discuss the structure A and structure B. In structure A, you can see here inside the nucleus there are 8 protons and 8 neutrons, and outside the nucleus in different shells 8 electrons are present. In the same way, in structure B, there are 8 protons but 10 neutrons, and outside the nucleus 8 electrons are present in different shells. Okay, now in structure A, how many electrons are there? 8. Number of protons? 8. So atomic number will be 8. Number of neutrons are 8. So mass number is 16. In structure B, 8 electrons are there and 8 protons. So atomic number will be 8. Number of neutrons are 10. So mass number will be 18. You have seen here atomic number is same 8 and 8, but mass number is different 16 and 18. So it's mean these both structures A and B are the isotopes of same element. Okay, now what are the properties of isotopes? Properties are maybe chemical properties or physical properties. Chemical properties related to composition of a structure, and physical properties related to appearance of anything. The chemical properties of isotopes are same. Why they are same? Because these properties depend upon the number of electrons. As we know very well, for the chemical combination, electrons are involved. So if electrons are not changing, number of protons are not changing, it means number of electrons are also same in the isotopes. So they have same chemical properties. But physical properties are different because these properties depend upon the mass number. Okay students, let's see how discovery of isotopes contradicted the Dalton atomic theory. As he said that all the atoms of same element have same mass. All atoms of same element have same mass, but after the discovery of isotopes, Soddy explains the isotopes are the atoms of same element have same atomic number but mass number is different. So the discovery of isotope was proved that some Dalton's ideas about the atoms were not correct. So there were contradictions in Dalton's atomic theory. Now let's start the discussion about the isotopes of different elements. The first element is hydrogen. Isotopes of hydrogen. There are three isotopes of hydrogen. Number 1, hydrogen 1, protium. Number 2, hydrogen 2, deuterium. And number 3, hydrogen 3, tritium. Hydrogen 1, protium. It has one proton in the nucleus and no neutron. 0 neutrons are present in the nucleus of hydrogen 1 and 1 electron is present outside the nucleus. Now what is the atomic number of hydrogen 1? 1, because protons are 1. And what is the mass? Mass is the sum of protons plus neutron, and 1 plus 0 is equal to 1. So it means it has mass number 1. So to write the symbol, we will write H11. The 1 at the top left is showing the mass number, and the one that is at the bottom left is showing the atomic number. Protium is naturally present in hydrogen 99.99%. The abundance of protium in naturally occurring hydrogen is 99.99%. Hydrogen 2, deuterium. It also has 1 protons, as isotopes have same number of protons but number of neutrons are different. Hydrogen 2 has 1 neutron and 1 electron is present outside the nucleus. Now what is the atomic number of hydrogen 2? Number of protons are same, so atomic number will be same, but now mass number is different. Protons 1, neutrons 1. 1 plus 1 is equal to 2, as sum of protons and neutrons called the mass number, so mass number is 2 and the symbol for the hydrogen 2 deuterium is H21. H and the top left 2 is showing the mass number and bottom left 1 is showing the atomic number of hydrogen, and its abundance is 0.0015. Isotope of hydrogen is hydrogen 3 tritium. It has same number of protons 1, but number of neutrons will different. It has 2 number of neutrons, so mass number become 3. Its symbol is H31. Top left 3 is showing the mass number and bottom left 1 is showing the atomic number, as its nucleus has 1 proton, so 1 atomic number, and its nucleus has mass number 3, so with the symbol H, 3 and 1 are written. 3 is showing the mass number and 1 is showing the atomic number. And the abundance of tritium is rare because it is a radioactive and its nucleus is unstable. It produces radiations all the time, so tritium is basically not found in naturally occurring hydrogen. Outside the nucleus, 1 electron is present. So it was all about the isotopes of hydrogen. Let's discuss the characteristics of hydrogen, properties of hydrogen. Okay, hydrogen protium is a colorless, odorless, tasteless, No taste is there, no color is there, and no smell is there. But it is highly inflammable. It catches the fire easily. It is readily burnable. And it is insoluble in water. Insoluble in water. Water. The formula of water, as we are familiar, is H2O. In H2O, hydrogen 1 protium is used. But if in the water, when H2 will react with oxygen and forms water, it forms deuterium oxide. Its formula will be D2O. Now, this water is known as heavy water. H2O is in which H1 protium is used is known as ordinary water, and D2O is known as heavy water. Let's discuss the characteristics of ordinary water and heavy water. The melting point of ordinary water is 0.00 and for the heavy water it is 3.81 degrees centigrade. Boiling point of ordinary water is 100 and for the heavy water it is 101.2. Density at 25 degrees centigrade for the ordinary water 0.99701 gram per centimeter cube, and for the heavy water it is 1.1044 gram per centimeter cube. In the same way, molecular mass of these both water will different. Molecular mass for the ordinary water it is 18 AMU, and for the heavy water these are molecular mass is 20 AMU. You can see here, by the changing of isotopes, H1 forming a water, H2 is also forming a water, but there is difference in their physical properties. The next element is carbon. So we will discuss the isotopes of carbon. Carbon has 3 isotopes. Number 1, carbon 12, then carbon 13, and then carbon 14. Now you can understand it very easily. This number 12, 13 and 14, these are the different mass numbers. We represent the isotopes with their mass number. Carbon 12, it means the atom of carbon whose mass is 12. Carbon 13, the isotope of carbon atom that is having mass 13. And the carbon 14, it means isotope of carbon that has mass number 14. Let's discuss carbon 12. It has 6 protons in the nucleus and 6 neutrons. If it has 6 protons, it means it also having 6 electrons outside the nucleus. In first shell 2 electrons, in second shell 4 electrons. So its atomic number is 6 but mass number is 12. As sum of protons plus neutron is mass number, P6 N6, 6 plus 6 is equal to 12. The symbol of carbon 12 is C12 and 6. Top left 12 is showing the mass number of isotope of carbon 12 and 6 at bottom left is showing the atomic number of carbon. The abundance of carbon 12 is 98.8%. Carbon 13, same number of protons 6 but number of neutrons will be different. These are 7. 6 plus 7 it is equal to 13 and it has 6 electrons outside the nucleus in different shells. Now what will be the symbol for carbon 13? It will be C13 6 and the natural abundance for the carbon 13 is 1.1%. Carbon 14 also having same number of protons, these are 6 but number of neutrons are 8 inside the nucleus of atom and 6 electrons are present outside the nucleus in different shells. The symbol for the carbon 14 will be C14 6. Top left 14 is showing the mass number of isotope of carbon 14, and 6 is showing the, at the bottom left, it is showing atomic number of the carbon. And the abundance of carbon 14 is very less, that is 0.009%. Let's discuss the properties of carbon. So, characteristics of carbon are different forms of carbon exist as black or grayish black solids. Means carbon is present in the form, exists in the form of solids. It has solid state and its color is black or grayish black, except diamond. Diamond is also exists as solid, but it occurs in variety of colors: gray, white, blue, yellow, red, orange, green, pink to purple, brown. Different colors of diamond are here. And carbon are tasteless. They don't have any taste. They are odorless. They don't have any smell. They are insoluble in water, and they have high melting and boiling point. Different forms of carbon has high melting and boiling points, and they are insoluble in water. Now let's discuss the isotopes of chlorine. Chlorine has two isotopes, chlorine 35 and chlorine 37. 35 and 37 are the mass number of the two isotopes of chlorine. The first isotope of chlorine is chlorine 35. It has 17 protons and 18 neutrons in the nucleus. 17 plus 18 is equal to 35. So mass number of chlorine 35 is 35. In the first shell, 2 electrons are present, and if we see its symbol, it is Cl, symbol of chlorine. 35, 17, 35 at top left is showing the mass number of isotope chlorine 35, and 17 is showing the atomic number of chlorine. Is it a complete structure of chlorine 35? No, because protons are 17, but we had drawn just 2 electrons. So in different shells, 17 electrons must be there. Okay, now it is a complete structure of chlorine 35. The natural abundance of chlorine 35 is 75.77%. The next isotope of chlorine is chlorine 37. Its mean, it has how many protons? 17. But neutron number will be different. It will be 20. Now 20 plus 17 makes 20 plus 17 makes 37. 17 electrons are present in different shells of chlorine atom. The symbol will be Cl, 37, 17. 37 at top left is showing the mass number, and 17 at bottom left is showing the atomic number of chlorine 37 isotope. The natural abundance of chlorine 37 is 24.23. Let's discuss the properties of chlorine. Some are the following characteristics of chlorine. They are grayish yellow gas. It means chlorine exists in the form of gas. That's why we said chlorine is a diatomic molecule. It exists as a gas. It is fairly soluble in water. And what type of smell it has? It has sharp, pungent, irritating smell. The next isotopes are isotopes of uranium. There are 3 isotopes of uranium: uranium-234, uranium-235 and uranium-238. These 234, 235 and 238 are basically the mass numbers of 3 isotopes of uranium. Friends, the first isotope of uranium is uranium-234. It has 92 protons and 142 neutrons inside the nucleus. and the symbol for uranium-234 is U23492, and the abundance of uranium-234 is 0.006%. If we see its structure, it has 92 protons and 142 neutrons inside the nucleus, and 92 electrons are revolving around the nucleus in different shells. The next isotope is uranium-235. Same number of protons, but number of neutrons are 143. Now the symbol will be U23592 and the abundance is 0.72%. Means U235 is present naturally 0.72%. If we see the structure of uranium-235, it has 92 protons and 143 neutrons inside the nucleus, and number of electrons are 92, which are revolving around the nucleus in different shells. The next isotope of uranium is uranium-238. Same number of protons, number of neutrons are different. These are 146 and number of protons are 92. Its symbol will be U23892 and its abundance is 99.27%. If we see its structure, it has 92 protons and number of neutrons are 146. And how many electrons are there? Yes, 92 electrons are there in the uranium and which are accommodated in different shells around the nucleus. Okay students, the fission of uranium-235 yields smaller nuclei, neutron and energy. The nuclear energy released by the fission of 1 kilogram of uranium-235 is equivalent to chemical energy produced by burning more than 17,000 kilograms of coal. So, uranium-235 isotope is used in nuclear reactors and atomic bombs. When uranium-238 decays into thorium-234, it emits alpha particles. Now let's see what is nuclear fission reaction and how alpha particles are emitted by disintegration of uranium-238.
The disintegration converts the uranium isotope into stable lead and in the process emits energy in the range of 1 to 5 mega electron volts. That's 1 to 5 million electron volts, and even higher amounts of energy can be released by breaking unstable nuclei into even more parts. In 1939, a German scientist named Otto Hahn discovered that breaking up the nucleus of uranium-235 into two parts emits 200 million times the energy of the neutron which triggered it. He, along with his two colleagues, Lisa Meitner and Fritz Strassmann, found that when the nucleus of uranium-235 is bombarded with neutrons, it will absorb one of the neutrons. This results in an unstable compound nucleus, and the nucleus breaks into two equal parts. This process is referred to as nuclear fission. So, a process in which heavy nuclei are bombarded with neutrons and split into two equal masses, releasing enormous amounts of energy, is called nuclear fission. In the process, uranium-235 initially absorbs a slow-moving neutron, thus forming a highly unstable compound nucleus, uranium-236. This is what triggers the nuclear reaction. During the process of fission, uranium-236 splits into two product nuclei, which are barium-141 and krypton-92. You should notice that a barium atom has 56 protons and a krypton atom has 36 protons, which add up to the uranium atom's 92 protons. The unstable uranium-236 nucleus also releases 3 neutrons in the process. This happens because barium-141 has 141 neutrons and krypton-92 has 92 neutrons, adding up to a total of 233 neutrons. To balance the equation, uranium-236 must emit 3 more neutrons. The chemical equation of the nuclear fission reaction taking place can be represented by this equation. So as you can see from the equation, 1 neutron combines with uranium-235, forming an unstable compound nucleus, uranium-236. This unstable nucleus splits into two stable nuclei, barium-141 and krypton-92. In addition to these two nuclei, 3 neutrons are also emitted, as well as a high amount of energy denoted in the equation by Q. Since uranium-236 emits 3 neutrons in the reaction, these neutrons can be absorbed by other uranium-235 nuclei, resulting in a chain reaction. This leads to exponentially high amounts of energy being released by a single reaction. So,
14 billion years ago are still in existence today, but not all nuclei are stable. Unstable nuclei either have too many protons or too many neutrons, upsetting the strong nuclear forces. Unstable nuclei try to balance themselves by giving off the excess proton or neutron. This is radioactive decay. Unstable nuclei are radioactive and emit radiation. There are 3 types of decay: alpha decay, beta decay minus, or beta decay plus. Alpha decay is the loss of an alpha particle. An alpha particle is made of 2 neutrons and 2 protons. They have a mass of 4 and a charge of +2. When an atom loses an alpha particle, the mass number decreases by 4 and the atomic number decreases by 2. A new element is formed that is 2 places lower in the periodic table.
Okay students, I hope you understand about the isotopes and isotopes of different elements. Now in next part I will explain the uses of isotopes in different fields. Till that, Allah Hafiz.